Now we briefly go over limits at infinity. Example 1. Calculate limit as x goes to minus infinity of 4x cubed plus 6x squared minus 2 divided by 2x cubed minus 4x plus 5. As explained already in previous lectures, this is very easy to calculate using what I call the box method. So what you do is you box the leading term of the numerator and denominator. So both the power and its coefficient. So this limit is the same as 4x cubed over 2x cubed, which is just simply 2. Remember that this means that we have a horizontal asymptote y equal to 2. Let's consider the next example. Limit as x goes to infinity of x squared over root of x to the power of 4 plus 1. Again, you can apply the box method. But be careful what you put in the box and how to interpret it. So the leading power of the numerator is x squared. The leading power of the denominator is root of 4x to the 4th. So this is the same as limit where x goes to infinity of x squared divided by root of x to the 4th, which is limit as x goes to infinity of x squared over absolute value of x squared, which is just x squared. So the answer is simply 1. That means that we have a horizontal asymptote y equals 1. Third question. Now suppose we are dealing with limit as x goes to infinity of root 9x squared plus x minus 3x. In this case, it's not written in fraction form, and it is best to complete the square and write it like this. So by writing it in this form, I now can resort to the box method. So that is 9x squared plus x minus 9x squared over root of 9x squared plus x plus 3x. Now when you apply the box method here, I'll first simplify it. What do we box here? In the numerator, clearly x. In the denominator, we box the leading power, which is root of 9x squared, but also 3x. Don't forget about it. So this is the same as the limit as x goes to infinity, x of root of 9x squared plus 3x. Now root of 9x squared is just 3x. Here x approaches infinity, so that's fine. It's positive. And the result is simply 1 over 6. Again, we have a horizontal asymptote, y equal 1 over 6. One more example. We now consider the final example. Again, we have a difference of roots. It's best to complete the square. That is then x squared plus ax minus x squared plus bx over root of x squared plus ax plus root x squared plus bx. So you can see that the x squares cancel out. What you have now is ax minus bx over root x squared plus ax plus root x squared plus bx. So we again can use the box method. The leading term here is this. On the denominator, it's x squared root and root of x squared. Now, because x is a positive number, x goes to infinity, we can simplify the root as just root of x squared being equal to x. So what we have is, this is just ax minus bx over x plus x. So the answer is simply x a minus b divided by x 1 plus 1, and we just get a minus b over 2.